Hello everyone. In this video, I will demonstrate how to create higher order models in SmartPLS. So this is the model we're going to work with. Details are provided in my earlier videos, so viewers are encouraged to listen and watch my earlier videos before coming to this one. This will help them understand the model technique I'm demonstrating here better. So basically it's a model where we have higher level of satisfaction will lead to higher level of commitment, which in turn will lead to higher level of retention, and higher level of satisfaction might have a positive impact on retention as well. And we are using 5-point Likert scale with higher scores denoting higher level of agreement with the statement. And we have given the scale here for retention, satisfaction, commitment, and stress. Retention specifically being used as a single item scale here. And in the earlier videos, we have talked about the sample size, missing values, outliers, and normality. So, and we also talked about the constructs. What are the difference between reflective and formative, and scores are standardized and for the path coefficient as well as loadings and weights. They range from -1 to +1. uh, Farther from 0 indicates strong relationship, so we have seen that. And when we talk about the assessing the model performance, we have to assess first the measurement model and then the structural model. So we're going to go ahead and build the model here in SmartPLS software. So this is the model we were working on. Now commitment, we are using just one subdimension here, but let's go ahead and build a second order construct. So I'm going to highlight this one, delete this one here, this one here. So we a commitment could be model as higher order construct with 3 first order construct as effective commitment, continuous commitment, and normative commitment. So we have effective commitment here. Let's go ahead and build a continuous commitment first order construct. So I'm going to highlight those things: 1, 2, 3, 4, 5. So we have 5 of those. So I'm going to bring them here. Rename as commitment, and then we're going to bring the normative commitment items. So 1, 2, 3, we have 3 of those. Bring it here. Right, we're gonna rename this one as normative commitment. Here, and we're gonna create a higher order construct, and the way it's created is using repeated measures approach, which means that we're going to select all of these indicators, all of them, and create a higher order construct like this here. They are all repeated, they are the same indicator as all of this here. As you see here, I'm going to highlight this and hide the indicators because it's going to be higher order construct here. And I'm going to connect this all the path arrows. So this is basically known as let's name this one first. We're gonna call this as commitment. So this is a higher order construct, and this is called reflective model, because we have first order construct as reflective and second order construct is also reflective. So reflective and reflective. Sometimes you have first order construct as reflective and second order construct as formative, where all these path arrows are directly inwards to the commitment. In that case, you're gonna call it as reflective formative model. But this is reflective, and here we're going to see that how we can assess the measurement model and the structural model. Again, when it comes to measurement model, we need to see how well these indicators are measuring each construct, here the first order construct and the higher level construct. And when you assess that, the next thing is we need to assess the structural path, the structural model, which is how this path coefficient are faring in terms of performance. So that's what we need to see here. So we're gonna go ahead and run this one. Now, since we have higher order construct here, we need to make some adjustment. In the literature, it's been shown that it's better to use factor weighing scheme when you're using higher order construct. So we're gonna select that one. Missing value, we're gonna use the case-wise deletion again, because we have a lot of missing values and there is no way we can do the mean replacement, and details are discussed in my earlier videos. So with that, I'm gonna say start calculation here. So first thing first, let's assess the measurement model. When it comes to assessing the measurement model, we have to assess the first order construct and the second order construct. So we're gonna talk about, let's say we're gonna talk about these three things again: convergent validity, reliability, and discriminant validity. So let's assess the convergent validity first. So convergent validity is assessed using loadings and average variance extracted. So let's do that here. Construct, let's say we want to show average variance extracted. So now it shows me the average variance extracted. We are just focusing on first order construct and other construct, not the higher order construct. Okay, so here the first order construct, all the AVEs are uh, greater than 0.5, and all the loadings are almost greater than 0.7. So everywhere you see is greater than 0.7 here. The only exception is, I guess, this one, but that is very close to 0.7. So with that said, that we can conclude that the convergent validity has been established for all the lower order constructs and other constructs in the model. Now we had to establish the convergent validity for higher order construct as well. And to do that is you have to basically see the loadings here. They should be greater than 0.7. All of them are, like, couple of them are greater than 0.7, and this is very close to 0.7. So what you can do is you can calculate the average variance extracted. Now this is not showing me the AVE for higher order construct. Okay, for the lower order construct and other construct, it shows me the AVE values, but this is not the AVE value. Okay, although it says that average variance extracted. Okay, to calculate the AVE value for the higher order construct, what you need to do is you need to average out the square loadings of all these three subdimensions. Okay, so you're gonna square this one up plus square this one up plus square this one up and divide it by 3, so you get the average variance extracted for the higher order construct. And if you see that they're all, two of them are almost 0.8 and this is almost 0.7, so AVE will be more than 0.5 for higher order constructs. So with that, we can conclude that we have validated the convergent validity aspect of the measurement model. The next thing is the reliability. The reliability has to be between 0.6 and 0.9, and we use composite reliability and Cronbach alpha. So we can do that here. I guess we have to go to the PLS algorithm run here, and there is a construct reliability and validity here. So look at the Cronbach alpha here for all the construct, including the higher order construct here commitment, they're all greater than 0.7, which is what we want. Retention has almost perfect value of 1, which is, it is because it is a single item construct, so we have to ignore that one. So, but as for the Cronbach alpha value, we can conclude that all the measurements or measurement models are very reliable. All the measures are very reliable measuring the constructs. So when it comes to composite reliability, which is supposed to be better than Cronbach alpha, again you can see the similar trend. All of them are greater than 0.7. The range is between 0.6 and 0.9, so they are all greater than 0.7 but less than 0.9, which is what we want. This is almost 0.9 here. But this is perfect one for the retention. We don't want it to be more than 0.9, because in that case basically we are saying that all those indicators that we have, they are same. So all these indicators are very similar to each other, and we don't want that thing. Okay, so that's something you have to keep in mind here. So with that, we can say that we have established the reliability for the measurement model, for all the first order construct, higher order construct, and other constructs in the model. Okay, this is our commitment is our higher order construct. Okay, so reliability is pretty high here, zero point 0.9 almost, 0.899. So that's something very good. Okay, so we have established the convergent validity, we have established the reliability. Now we have to discuss the discriminant validity. Now when it comes to discriminant validity, we look at how well this for a first order constructs discriminate among themselves, and how well they kind of discriminate from other construct like satisfaction and retention, and we want them to have a discriminant validity. That means they should discriminate well from all other constructs among each other and other constructs. Okay, but we do not evaluate the sort of discrimination between first order construct and a higher order construct, because this higher order construct is simply has been created by uh, copying all the indicators here. So it's a repeated measures indicator, or repeated measures construct here, because we are using all the same indicators here. So it doesn't make any sense to establish discriminant validity between lower order construct and higher order construct. But we need to make sure that all these lower order constructs, they again discriminate well among themselves and from other construct in the model. So for that, we gonna look at the STMT values here. So if you go our run here, PLS algorithm here, we had to look at the discriminant validity, and we have to look at the formal Lorker criterion first. And it tells me that basically it tells me that the average variance extracted, or the correlation basically of the construct with its indicator, should be greater than the correlation that this construct has with all other constructs. Okay, so if you do that, that means you're establishing discriminant validity. And the logic there is, a construct is supposed to share more variances among its indicator compared to other construct. So it should be more correlated to its construct, to its item, than to other construct in the model. And again, when it comes to discriminant validity, we're not going to do that for higher order construct. Okay, so we're just going to ignore commitment here, but we're going to do that the effective commitment is 0.8. It is greater than continuous commitment, normative commitment, retention, and satisfaction. So we established the discriminant validity for effective commitment. For continuous commitment is a similar trend. They're all greater than uh, all other, this value is greater than all other constructs here, including effective commitment here. And likewise, normative commitment is greater than retention, satisfaction, and continuous commitment and effective commitment. And retention is the similar thing here. So we established the sort of discriminant validity here. Another measure is head rotate monotrade. Again, we're not going to do it for the commitment, but for all other constructs. So effective commitment with continuous normative retention and satisfaction, they're all less than 0.9. Likewise, for all other constructs, you see that, like for example, continuous commitment is less than 0.9 for all other construct, normative commitment, retention, satisfaction, right? And as well as normative commitment here. Okay. Okay. So that's something you have to keep in mind. With that, we can sort of conclude that we have established the discriminant validity. Okay. So so we are sort of done here. We need to make sure that the confidence interval does not include 1. For that, we had to run bootstrapping, which we're going to do here. So I'm going to go here, go to bootstrapping here. Let's do only 200 samples, but in reality, when you're doing the actual research project, you have to do 5,000 samples. That's something you have to keep in mind. Complete bootstrapping. is what we want, because this is going to give us the confidence interval for HTMT measures. Bias corrected one is the most conservative one, so we're going to select that. Two tail test and 0.05 significance level. Partial least square, so we're going to do the factor, because it's being said that if you're using higher order construct, you should use factor weighing scheme, as it produces more stable results. And for the missing value, we are selecting case-wise deletion, and we're gonna say start calculation here. So bootstrapping run here, we are looking for STMT head rotate monotrade ratio here. And if you see here, none of them includes you know uh, 1. Okay, that's what we're looking for. And we're not going to do commitment to effective commitment, because commitment is higher order and this is lower order, but we have to do all the lower order. So this one is there, doesn't include 1 continuous commit. This we're going to ignore. This one, the 95% confidence interval doesn't include 1, so it's good here. This one we're going to ignore, because commitment again is higher order construct and normative commitment is lower order construct there. This one we're going to consider, because they both are lower order construct, doesn't include 1 here. So likewise, if you see it, they don't include 1, so we have sort of established a discriminant validity. So the last thing we have to do is, once we assess the measurement model, we have to assess the structural model. Okay, and structural model, which means that we have to first look at the multicollinearity issue. So if you look at here, we have to first assess the multicollinearity issue between the constructs. Okay, and then we have to assess the significance of path coefficients, and then we have to assess the R-square value. So let's see that we have already run the bootstrap, which sort of produces the VIF values. VIF values will also be provided here. Let's see. Okay, VIF value is provided here in the PLS algorithm, but not here. So that's something you need to keep in mind. So we have to go to PLS algorithm and click on collinearity statistics here, and we are looking at the outer one is for the measurement model. The inner VIFs are for the structural model, and we need to make sure that if you look at the structure here, we are predicting retention using commitment and satisfaction. So these two should not be correlated to each other to a great extent, and commitment is being predicted by satisfaction. So there is only one variable here, so no question of multicollinearity. So in fact, we have to just see the VIF values between commitment and satisfaction. And so if you see commitment and satisfaction is 1, uh, which is less than 5, so I would consider this as good. They are not correlated to each other as much. Okay, so this one I'm going to ignore, because these are normative, commitment, continuance, and effective. They are just part of commitment. uh, so when it comes to the retention, commitment, and satisfaction, the VIF value is very low, less than 5, which is what we want when it comes to the retention. And when it comes to the commitment, there is we are using satisfaction. So only one variable there. That's why it's 1 here. Okay, that's something you have to keep in mind. So since the retention is being predicted by commitment and satisfaction, and since the VIF values between these two uh, factors are less than 5, we can say that confidently that there are no multicollinearity issues. That satisfies our assumption there. The next thing we have to look at is the path coefficient significance. So all these path coefficients, so we have the bootstrapping result here. We can check it right here. So it's showing us the p-value as well. So all these are less than 0.05, less than 0.05, right? So that's significant. Um, Not this one, I'm sorry, this one is the loading, but here 0.78578 significant, and this is also significant. So this tells me that all the path coefficients are significant at 0.05 level. Obviously satisfaction has a very high impact on commitment, positive impact, and commitment in turn has a very high positive impact on retention. And satisfaction has a direct effect which is significant, but the strength is not as high as the indirect effect here. We're going to talk about more about direct effect in the another video, when we're going to consider what we call uh, the mediating effect. Okay, so we're going to do that separately. In fact, we can do that here. uh, for example, if you see the indirect effect, they are more significant, and the way you calculate the indirect effect is if you just multiply 0.442 times 0.578, that's going to give you the indirect effect. So let's do that. So let's say 0.442 times 0.578, 0.578, that's 0.255. And if you go here and say indirect effects, we're gonna see that, okay, this is gonna give us the p-values. They're all significant here, but if you go to PLS algorithm here, indirect effect, you're gonna see the 0.25 here, right? So the total indirect effect of satisfaction on retention via commitment is 0.256. Okay, uh, this we have to ignore because they are not directly linked. Affective commitment, continuous commitment, and normative commitment, they are first order construct, and we are not predicting them using satisfaction. So we have to ignore those things there. But satisfaction has total indirect effect uh, of 0.256. And if there is something called total effect as well, so if you add this one indirect effect to a direct effect of 0.132, you'll see the total effect. So total effect should be 0.25 plus 0.13. Okay, so that should be 0.38 or 39 something. Let's check it out. See, 0.388. That's what you're looking for, the total effect. So total effect is the sum of indirect effect and the direct effect. Path coefficients give you the direct effects. Indirect effects gives you the indirect path, like 0.442 times 0.578. That's the indirect path to retention. That's your indirect effect. And total effect is the summation of the two, and they're all significant. So because you can go here, bootstrapping here, path coefficients here, all the path coefficients are significant, especially these three. We're not worried about these three because they are the higher order constructs, but we have these path coefficients here. They're all significant. And if you check the confidence interval, they won't include zero. Okay, so if they're not including zero, that means the p-value is significant, and that's why we see it here. Okay, so we don't need to worry about that. So once you so we have sort of look at the VIFs among the set of predictors. They're all less than 5, especially when it comes to predicting the retention. And we also check all the direct effects, indirect effects, and the total effect. They're all significant at 0.05 level. And the next thing is we have to assess the R-square value. So to see how much variation is being explained by the model, so we can see here, let's say I need to go to the PLS algorithm run here and say show me the R square. Okay, So this basically tells me that 20% of the variation is being explained by satisfaction, and 41% of the variation in the retention is being explained by satisfaction and commitment. Okay, that's something you have to understand. So overall prediction is around 41%, 42% for the retention, which is pretty huge. This should be considered as a moderate effect. Okay, so that's a takeaway from this model here. The next model probably we going to introduce some formative measures, but we have sort of addressed all the issues of the measurement model in the structure model. With that, I conclude this video here. Thank you very much for listening.